Hello, welcome to the Chapter 12 and 13 review packet for Mr. Wagner's geometry class. We'll jump right into the questions, but these directions first. You can use a non-graphing calculator and the formula sheet for this. You'll be able to use that on the test as well if you're in my class. All work must be shown in order to receive credit, so find the requested information for each solid. Be as specific as possible when you're naming the figures. Write the formulas and round answers to the nearest tenth if necessary, including units in your answers. So let's take a look at number one, considering all that. So number one, we've got a figure, lateral area, surface area, and volume, all that to figure out. And we're going to assume that this shaded part here, that's the base that we're going to need. So for a prism, like we have here, a rectangular prism, that is the name of this shape. If you say box, tell me what you mean by that. So a box is a rectangular prism. So from there, lateral area is going to be everything but the bases. So you're not going to include the base here, and the parallel base up there would be that. So the lateral area for a prism, you just have perimeter times the height. So the perimeter of the base is what that stands for. So here you would have, if we're going to say that this is the base, you're going to have 6 plus 3 plus 6 plus 3. That's your perimeter. And then your height would connect the two bases, so that would be the 4 right there. So this is going to be 18 times 4, and it looks like that is 72. So depending on whether or not you used a different set or pair of parallel faces for the bases, you may have a different answer than this. You might have 84 or you might have 60 if you used this side and this side instead of the bottom and the top, or if you use the front and the back, you may have different answers. But 72 centimeters squared if you do the lateral area considering these two, the top and the bottom, as the bases. So again, 72 centimeters squared for area, and you could have had 60 or 84 are also possible other answers depending on how you decide to calculate that lateral area, depending on what you pick for the base. So from there, let's look at the surface area. That is not going to be any different no matter which one you pick. So surface area is the perimeter times height, the lateral area plus the two bases. So I've already done the lateral area. The pH part is 72. I'm just going to replace pH with 72. And then 2 times the area of the bases. These bases are just rectangles. So you've got 6 and 3. 6 times 3, base times height. And that would be 72 plus 2 times 18. That's going to be 72 plus 36 for a grand total of 108 centimeters squared for the surface area. So 108 centimeters squared going right here. And then the volume is going to be the area of the base times the height. That works for any prism. Rectangular prism, the base is going to be length times width, or base times height, little base times little height here. So you'd have 6 times 3 would be the area of the base times the height would be 4. So you have 18 times 4, and once again that is 72. This one's going to be centimeters cubed though. Why cubed? Because it's a volume. You're multiplying 3 measurements together instead of just 2 measurements together. So 72 centimeters cubed. Number 2, we've got a triangular prism on this one. You have a triangle face here and here. Those are the parallel parts, the parallel faces of that prism. Triangular prism. So this is the base, and this is another base. Those are the parallel parts to this. These rectangles, the 3 rectangles as you go around laterally, are going to be the sum of those, the lateral area. So the lateral area is still perimeter times height. Perimeter of the base is what that's referring to. The perimeter of the base, well, we have to figure that out here. We know this is 12 right here, so this would be 12 right here as well. And if this is 30, you have a 30, 60, 90 triangle, since that's a right angle. So you can use your 1, 2, rad 3 ratios, and this would be the 2 times bigger part, or the 2x part. This would be your the part across from the smaller angle is going to be the smaller side. That'd be your x part, and this is the x radical 3 part. And so from here to this side, we would need to know that divide by 2. Going from 2x to x, you're going to have 6 right here. And then if you're going from x to x times the square root of 3, that's just going to be 6 times the square root of 3. So then you have your perimeter of the base. You've got 6 plus 12 plus 6 times the square root of 3. That times the height. The height connects the two bases. This is your height in this case, because it's connecting the base here to the base here. So the bases of the prism are those triangles, the height then 15. And if we simplify this, we're going to have 18 plus 6 times radical 3 times 15. And so we could distribute the 15 to both parts, but this is saying round to the nearest tenth. This is one we'll be rounding off here, so that is approximately 425.9. So 425.9, and that would be centimeters squared. We're talking lateral area on this one. So 425, 0.9 centimeters squared going right here. Surface area is going to include that plus the two bases. So you have surface area equals lateral area plus the two bases. So you're going to have the pH part and you're going to have the two bases. The pH part we've already figured out, about 425.9, and then adding the two bases. The base is a triangle, and the area of a triangle is 1/2 base times height, little b, times little h. The perpendicular parts here are the little b and the little h. So we have times 6 radical 3. This is going to be approximately 425.9 plus, this would be 2 times 1/2 would be 1. So it's just 6 times 6, 36 times the square root of 3. So if I add, and I'm just going to leave in my calculator, I had rounded this off, but I still have the more accurate answer saved without rounding it as much in the calculator, without rounding at all, and just keeping the digits, all the digits that were there in the calculator. So I'm going to add 36 radical 3 to that. I'm going to be doing some work on the calculator as I talk here, but you won't be able to see that work. But it's 488.2. So I'm using a handy dandy TI 30X2S. You could use any calculator that you have handy right there for you. So 488.2, that many feet squared, and I should have said feet squared up here. That was my mistake there. So let me change that. So this should be feet. Make sure you're including the appropriate units. And so we'll put that here. 488.2 feet squared. The volume is going to be the area of the base times the height. So the area of the base, that's the 1/2 base times height for the triangle, 1/2 little b times the height. So you've got 1/2 times 6 radical 3. That is your b. And your h is going to be the part that connects the bases, 15. So we've got 36 here times 1/2. That'd be 18 times the square root of 3. That times 15. And if I put that into a calculator, we've got 18 times the square root of 3 times 15. Looks like I've got 467.7 approximately. So 467, put my approximately equal to sign, 467.7, and we're talking feet cubed now for a volume. So 467.7 feet cubed. Beautiful. Let's move on to number 3. Number 3, we have, it looks like a trapezoidal prism. If you want to be even more specific, because of this mark here and this mark here, those congruent marks would mean an isosceles trapezoidal prism. So if you want to be as specific as possible, as the directions say, we would say isosceles trapezoidal prism. If you said trapezoid prism, I'd be okay with that. That is a horrible looking A. Let me make that a little better looking there. So trapezoidal prism. All right. If you just say trapezoidal prism, we'll accept that too. But from there, the base, now we're going to figure this out first. So B, that's going to be the trapezoid parts, because those are the parallel faces. You've got, for a trapezoid, it's the average of the bases times the height. If you're one of my students, please, on the test, write your formulas in general first, and then fill in the numbers from there. That way I know exactly what's what, and I know that you know where the numbers came from. So the base 1, we're saying this is 2 from here to here, all the way from this point to this point. And if you make a little triangle coming down this way, that would be the same as this right here. 1.5 is going to be that length as well. So I'll make another little arrow right there. That's going to be 1.5, since that's 1.5. And you could do the same thing over here. And now this is not drawn to scale necessarily here, but it's isosceles. If this is 2 from here to here, like it is up here, that would have to be 1 here and 1 here. Since it's isosceles, those have to be split up evenly. Since we have 4 all the way across, 2 of it's here, you have 1 left over for here and here. And so it looks like that may help me later in the problem. We'll see here. I might not even have to know that. Let's see what we got here. So 2 plus 4 over 2, that would be base 1 plus base 2 over 2. So the average of the bases times the height. So at least I don't need that part yet. So times the height. The height I'm told is 1.5 right there. So 1.5, this is going to be 6 over 2, which is 3. 3 times 1.5 would be 4.5. And this is the area of the base. Capital B is always standing for the area of the base here, 4.5 centimeters squared. So now that I know that, I can find the lateral area, or the surface area. Actually, lateral area, I don't even need that part. So I'm going to do the perimeter of the base times the height. So the perimeter of the base, here's where I do need to know that this is 1 and this is 1. Because to find the perimeter of the base, I need to add 4 plus whatever this is, plus 2 plus whatever this is. So to figure that out, since this is 1.5 and this is 1, if I look at this green triangle right here, I notice I can use the Pythagorean theorem on that. And I'm going to do, for that, 1 squared plus 1.5 squared equals, and why don't I just call this x, so equals x squared. This would be 1, and 1.5 squared would be 2.25, so I'd have 3.25 equals x squared. That means, or that implies, that x would be the square root of 3.25. And so if I plug that in, or think about that as I calculate this, my perimeter would be 4 plus the square root of 3.25. So 4 square root of 3.25, 2, and another square root of 3.25, since these are the same. So I've got that, and I've got that. So the square root of 3.25, you could say 2 times that instead of writing it twice. That would be okay as well. And then the height, connecting the two bases, is 6. And so from there, if we simplify this, we've got 6 plus 2 times the square root of 3.25 times 6. Really, I don't have to write that step out. We're going to be rounding this one to the nearest tenth here. I could get this in an exact form, but I'm just going to approximate this. So 6 plus 2 times the square root of 3.25. Looks like that is about 9.6, but if I keep that in my calculator, multiply it by 6 exactly, I got 57.6. So this is approximately 57.6, and that's going to be centimeters squared. So here, 57.6 centimeters squared. Surface area is the lateral area, pH, plus the two bases. And I already know what B is, so I'm just going to put that in right here. This was an exact number. So this is, the pH was rounded off. That's approximately then a total of 57.6 plus 2 times 4.5. That's 9 right there. So if I add 9 to 57.6, I've got 66 0.6, that many centimeters squared. And then volume, since it's a prism, same formula as before, base times height. The area of the base, I've already calculated that, 4.5. The height, I know that is 6. So 6 times 4.5, that is going to be 27. That's 27 centimeters cubed on this one. Moving on to number 4. Number 4, we have a regular solid here, so we're assuming that this is a regular hexagon right there. That's going to be important as we calculate this one. So I'm going to put a little center point for that regular hexagon. I need to know for the figure that it's a hexagonal prism. And then surface area and volume. We're leaving lateral area out on this one. We're saying surface area. So the base I can calculate using 1/2 perimeter times apothem on this one. For any regular solid that's not a square, that's the approach we have to use. So we think of this as the apothem, and the perimeter would be 6 times, there's 6 sides, so 6 times 6. So on this one, you've got 6 times 6, but we need to calculate that A value. So A, well, we know this angle right here is going to be 30 because it's 360 divided by 6. You can make 6 blue triangles just like that one, and then you divide that or cut that in half. So 30 coming from 360 divided by 6 split in half divided by 2. So that's where that number comes from. So you have 30 degrees. If that's 30 degrees, you have a 30, 60, 90 triangle. So yes, you could use SOHCAHTOA, you could use trig, but even easier to figure out that apothem, I'll do the apothem in green here. We could say that, well, I think I'm going to make a little green triangle here just to make this a little easier to see. And I'll just expand that out here. So this is just a blown up version of that, or a larger version of that triangle. We're saying that this is 30 degrees right here. This is your apothem. And we know if it's 6 all the way across, that has to be 3 right there. And then your ratio would be the 1:2 rad 3 ratio. This is twice as big. The hypotenuse is the biggest part. Your 1 part is right there. And then the square root of 3 is about 1.72, so that's the long leg instead of the short leg. So we have x times the square root of 3. And if I know this one, I can go right to this one by just multiplying by rad 2. So A is going to equal 3, or times rad 3, I mean. I said rad 2, I think. So A is 3 times rad 3. So if I plug that in right here, I've got 3 times the square root of 3. That would be 1/2 of 36, which would be 18. And 18 times 3 would be 54. So we have 54 times the square root of 3. Best to plug it in like that later, but this would be approximately, so 54 times the square root of 3, it looks like approximately 93.5 rounded to the nearest tenth. So 93.5 rounded off. 93.5, I'm going to write both answers down here though. So this, or approximately 93.5, and this would be the area of the base. It's inches for units, so inches squared right there. So let's keep going. Surface area is going to be the lateral area, or perimeter times height, in other words, plus 2 of the bases, 2 times the base. You got a base here, then you would have another hexagon back here that you can't see. It's not actually drawn in there, but that's where it would be. And then you'd have, that is pretty bad hidden lines there, but that's the idea. You got a base here and a base back here. You got some hidden lines. So it kind of looks like that behind the surface or beneath the surface. So we have the perimeter of the base. Well, that's just 6 times 6. The height of the prism is going to be, it looks like they're telling us that that's 12 inches. It looks like that is a safe assumption. So from here to here, that has to be 12. And then plus 2 times the base area of the base. I've calculated that. That's right here. So 54 times the square root of 3. So this would be 36 times 12. 36 times 12 is 432. So we have 432 plus 108 times the square root of 3. And that is approximately 619.1. So that is inches squared in this case. So let's write that down here, 619.1 inches squared. And then the volume, it's still a prism. We're doing all our prisms at once, it looks like here. We're starting off at least with a lot of prisms. The base, 54 rad 3, 54 times the square root of 3, times the height, which is 12. So 54 times 12. Looks like this exact answer would be 648 times the square root of 3. That would be an exact answer, and then an approximate answer. Take that, multiply it in a calculator, and it looks like we would get 1,122.4. So 1,122.4, and this would have been inches squared here. This is volume now, inches cubed instead. So approximately 1,122.4 inches cubed. Number 5. Now we have a cylinder. So figure, this is just a cylinder. You could say a right cylinder because it is at a right angle, or it's not on a slant at all, but we'll just say cylinder is acceptable. Lateral area for a cylinder is this part around it. So if you remember, if you cut that apart, or if you were to cut it right along here, something like that, and unfold it, you'd have a rectangle, and that rectangle would have a base of the circumference, the same length as the circumference all the way around. So you've got circumference times the height, or in other words, 2 pi r times the height. So from there, you've got 2 pi times, and the radius is given to you right there, it's 2. The height is given to you right there, it's 8. So this would be 2 times 2 is 4, 4 times 8 is 32. 32 pi, and we're given units as feet, so 32 pi feet squared. Surface area, we have lateral area plus the two bases. The two bases are both circles in this case, so the formula in general would look like this. So we've got 2 pi rh plus 2 pi r squared. So that's going to be, we've already figured out the 2 pi rh part, it's 32 pi. And we'll need to do that again. And then 2 pi times radius squared. 2 pi times 2 squared. 2 squared is 4. 4 times 2 is 8. So you're going to have 32 pi plus 8 pi for a grand total of 40 pi. So you should know how to give an answer both in terms of pi and in terms of a rounded off answer. So 32, I meant to say 32 pi here, there we go. 32 pi feet, don't forget that, and that would be, if I multiply 32 times pi, looks like approximately 100.5 feet squared. So 100.5 feet squared right here. And 40 pi feet squared would be approximately, let's do 40 times pi. Use the pi button on your calculator. Don't round off to 3.14. Use the whole pi button value, what you get in your calculator. About 125.7 if we round that off. So 125.7 feet squared rounded off. And then that we'll put here, so 40 pi feet squared, or approximately 125.7 feet squared. And then the volume is going to be the area of the base, so capital B times h, but the base is a circle, so you can just write pi r squared times h. You got pi times 2 squared times the height is 8. That would be 4 times 8, 32 pi. And so that looks familiar. I already did that work right here. I plugged that into a calculator before, so 32 pi, or approximately 100.5. But now this is feet cubed. So 32 pi feet cubed, or approximately 100.5 feet cubed. Number 6, we've got another cylinder. We would have, if you wanted to draw that part in, that's what the rest of it would look like beneath the surface. But if this is 20, the diameter, this has to be 10 then from there to there. So you've got 10 feet is your radius. 20 feet is the height connecting the two bases, and the figure is another cylinder. Lateral area for a cylinder is going to be the 2 pi r times h, and that's 2 pi times 10 times 20. 10 times 20 is 200, 200 times 2 is 400. So you have 400 pi, or approximately 400 times pi in the calculator, looking like I got 1256.6. So approximately 1256.6, and that would be in feet squared on this one. So you could say 400 pi feet squared, or approximately 1256.6 feet squared. Surface area is just that, the lateral area plus the two bases, so 2 pi r squareds in this case. They're both circles. We have 400 pi. I'm going to use that instead of the rounded off answer. It'll give me a better answer. And then 2 times pi times 10 squared. 10 squared is 100. 100 times 2 is 200. So you have 400 pi plus 200 pi. That would be 600 pi. And that's typed into a calculator. 600 pi is 1,884.95, so we round that up to 1,885.0. 1,885.0. We would say that many feet squared here. So this is a good answer there. This one is going to be the answer there. So we have 600 pi feet squared, or approximately 1885.0 feet squared. And finally, the volume is going to be the area of the base, pi r squared, times the height. We got pi times 10 squared times the height is 20. 10 squared is 100. 100 times 20 would be 2,000. So this would be 2,000 pi in this case. We round that off and we approximate that. 2,000 times pi, about 628. I'm not saying that right. 6,000. There we go. 6,283.2. 6,283.2 feet cubed. So you could say that or that, depending on what the problem is asking for. If it says leave it in pi form, write it like this. If it says give an exact, rounded to the nearest tenth, give it like that. So feet cubed right there. Number 7. We have a sphere now. What is the figure? This is a sphere. And then this one specifically saying in pi form, and then this one specifically in decimal form. So the volume and surface area of a sphere. Surface area is, it's like 4 circles. If you take a baseball and peel it apart, it looks like more or less like 4 circles. So 4 pi r squared, that's how I remember that formula. We have 4 times pi times 7 squared. 7 squared is 28, and 28 times 4 is 112. So 112 pi, that would be in pi form. This one we don't have to round off because it says to leave it in that form. You could type that into a calculator though very easily if it didn't say that. So 112 pi feet squared. And then the volume in decimal form, we're going to have well, before I move on, I noticed a mistake I made. I said this was, what did I even say? I don't know, 28? I don't know why. I was thinking this times this. What is 7 squared? That's 49. So 49 times pi is, or 49 times 4, I mean, is 196. So we have 196 and not 112. So my fault there. 196 pi, not 100. Ugh. Not 112. 196 pi. Volume is 4/3 pi r cubed. So you've got 4/3 times pi times 7 cubed. 7 cubed is 343. So I'm going to write 4/3 times pi times 343. And then this as a decimal, well, you could get this in pi form. If it said pi form, we'd say this is like pi over 1, this is like 343 over 1. Multiply all the tops together, multiply all the bottoms together. 4 times 343 would be 1372. 1372 pi on the top and then over 3 on the bottom. That would be pi form, but this as a decimal, multiply by pi, divide by 3, we've got approximately 1436.8. So approximately 1436.8, and that would be feet cubed. Number 8, we have a hemisphere here. We have half a sphere or a hemisphere. And then the surface area in decimal form and volume in pi form. The surface area of a regular sphere is 4 pi r squared. So for a hemisphere, you're going to have half of that. However, you're also going to have this circle, this great circle that's actually showing, where with a sphere you didn't have that circle at all. You didn't have any circle showing. You just had the outside of the sphere. But now we have this half a sphere, so 2 pi r squared, in other words, plus another pi r squared. So you've got 3 pi r squared really anytime you have a hemisphere. And so this would be 3, and then the radius, since this is the diameter, divide that by 2, your radius is going to be 4 inches. So divide by 2 to get your radius. We've got 3 times pi times 4 squared. 4 squared is 16. 16 times 3 is 48. 48 pi. This says in decimal form, so let's type that in. 48 times pi. Looks like we got 150.8. So 150.8 approximately. And that would be in inches squared. And then the volume in pi form now. Well, the volume, that doesn't depend on more of the surface showing. That's just going to be half of a sphere. So you're going to have half of what you normally have. Half of 4/3 pi r cubed. So you have 1/2 times 4/3 times pi times the radius is 4, so times 4 cubed. This says pi form, so we got to get this in exact form here. We're going to have 1/2 and 4/3 pi. 4 cubed is 64. So really think of these as all fractions. 1/2, 4/3, pi over 1, 64 over 1. You can multiply all the tops together, and you can multiply all the bottoms together. If you wanted to reduce first, you could do that too. I'll do that here. So the tops, I could reduce this. I could make that a 2 and this a 1. And then that's can't be reduced anymore, it looks like. So I've got 1 times 2 times pi times 64. That's 128 pi on the top. We got 1 times 3 times 1 times 1. So that is 128 pi over 3. That would be my final answer. Inches cubed right there. So you could write it like this, or you could write 128 over 3 and then a big pi on the outside. That would mean the same thing. So that inches cubed. Number 9. A sphere has a circumference of 72 meters. Find the following. We're going to find the surface area and volume. So the sphere, if it has a circumference, that's this great circle part. All around from there, wrapping all the way around to there. We're saying this part right here, wrapping around. That circumference is 72 meters. So the circumference of that circle, that great circle, is going to be 2 pi r. So you're going to say 72 equals 2 pi times the radius. You divide both sides by 2 pi and you have the radius. So that would be 36 on the top. If you reduce that, 36 over pi is your radius. So we're going to take that. You could approximate that, but let's leave it like that for a better answer in the end. Surface area is going to be, for a sphere, 4 pi r squared. So just plug that in to a calculator. 4 pi times 36 over pi squared. And so let's see what we get. If you type that in carefully into the calculator, using parentheses where appropriate, you're going to have 4 pi, and then if I have 36 divided by pi, I'll put that in parentheses and square that. It looks like I should get 1,650.1 rounded off. So approximately 1,650.1, and that would be meters squared. The volume is 4/3 pi r cubed. So let's write this before I forget to do that. That would be right there. But 4/3 pi r cubed, 4/3 times pi, and then times 36 over pi, but that cubed. Approximately, if you type that into the calculator, do that a second here, 4 divided by 3 times pi, and then times, in parentheses, 36 over pi to the third power. Looks like I have 6,302.98. So if I round that off, best answer looks like would be 6,302 or 303.0. So 6,303.0. That would be meters cubed. Number 10, the shape here, this is a cone. You could say a right cone since it's at a right angle, or straight up and down, but cone would be acceptable. So from there, volume, surface area, lateral area, we're going to figure out all three of those things. The lateral area for a cone is that kind of that strange one, pi RL, but you can calculate that using proportions, setting up the area of this sector to the area of the circle created by the net. If you cut this cone out, then you can compare that to the circumference and the arc length. Great proof of that is in your book if you really want to understand where that comes from. But pi times 10 times, well, the slant height, I don't know that yet, but I can figure that out pretty quickly. This would be my L right here. I have Pythagorean theorem I can use on this one. So I've got 12 squared plus 10 squared would equal L squared, slant height. This would be 144 plus 100. So you've got 244. If you take the square root of that whole thing, the square root of 244 would equal your slant height. So we plug that in. You could round that off, but best not to do that until the very end. So we type this into a calculator, and it looks like, let's take a moment to do that, pi times 10 times the square root of 244, and it looks like 490.7. So 490.7, that many feet squared for lateral area. 490.7 feet squared. Surface area is the lateral area, pi RL, plus, then you only have one base now. That base is a circle in a cone, so pi r squared. We figured this part out already, so it's approximately 490.7 for the pi RL part plus pi times the radius squared. Radius is 10. So you got about 490.7 plus 100 pi. So I still have that saved in my calculator, not rounded off. So this will give me my best answer, times 100 pi, approximately 804.9. So 804.9, and that is feet squared once again for an area. So 804.9 feet squared. Volume of a cone, it takes 3 cones to fill up a cylinder of the same base size and the same height, so it's 1/3 base times height. And the base being a circle, you can write pi r squared instead of b. Excuse me. So this would be 10 squared, and your height is 12. If we put that into a calculator, or calculate it without a calculator, this would be 100. 1/3 of 12 would be 4, so that'd be 400 pi. 400 times pi is approximately 1256.6. So 1256.6, that many feet cubed. Feet cubed, since it is a volume. Moving on to number 11, another cone. This one looks like we're given the slant height. We don't know the straight up and down normal height. We know the diameter is 10, so we know the radius would equal 5. So let's figure out what this is. First of all, it's a cone. Lateral area is going to be pi r L. So you've got pi times 5 times 15. That would be 75 pi. And 75 times pi. If we round that off, we get about 235.6. So 235.6, that'd be feet squared. If it said leave it in terms of pi, we'd say that, but I'll write the approximate answer here. So 235.6 feet squared. Surface area is that lateral area plus the base plus the pi r squared. So you've got 75 pi plus pi times the radius is 5, so plus that you would have 75 pi plus 25 pi, 100 pi, and that's approximately, well, 3.14 is pi, so 314, and then 159,265. So we've got 314.15. We would round that off to 314.2 to the nearest tenth. So 314.2 feet squared. And the volume, you're going to have 1/3 base times height, 1/3 pi r squared times the height. 1/3 pi, and then radius is 5, so 5 squared times the height is not 10 but 15. This would be 25, and then 1/3 of 15 would be 5, so I'm just multiplying things in whatever order I desire. The commutative property of multiplication says I can do that. So 1/3 of 15, 5 times 25 is 75. I would have 75 pi, and I've already calculated that. But I just realized the mistake I'm making. Have I found height yet? No, I haven't. This is the slant height. So this h here, I have to solve for that. So I have h squared plus 5 squared equals L squared. L is that, so I do want to erase this right here. That's going to be different. This would be h squared plus 25 equals 225. So you'd have h squared would be this excuse me, 225 minus 25 would be 200. So you'd have h is the square root of 200. So that should go in right here, square root of 200. And so that's going to change this, and we were going to have, so let's just type that into a calculator. 1/3 times pi times, that'd be 25 times the square root of 200. And that's going to be 370.2. So approximately 370.2 there. And that would be feet cubed in this case. So 370.2 feet cubed. Alright, this one, we're starting to do some pyramids here. So this one, you've got the, looks like a lateral edge here is 15 inches. And you're saying this is a square. Even though it doesn't quite look like a square, we're going to assume it because it says this is 12 and this is 12. So we don't know the height. We don't know h. We do know this edge, but we're going to have to basically figure out, let me erase this here, we're going to have to figure out some stuff in this triangle. We don't know the L part, and we don't know the H part right here. We do know that if this is 12, though, that would be 6 right there. So we know an edge is 15. We know that this would be, so 15, look at the green triangle that I'm making here, we know that we have another triangle like this, where this edge is 15 that I'm drawing last, 15 there. This would also be 6 right there. So it looks like we have another right angle right there. It looks like I might be using those two triangles to figure some stuff out in this one. So as I look at that, the figure, that's definitely something we would call a square pyramid, because this and this side are congruent, and it's pyramid. It meets at a vertex point like that. All the lateral faces are triangles. So a square pyramid, lateral area for a pyramid is 1/2 perimeter times the slant height. The perimeter puts all the sides together instead of just doing 1/2 base times height times every single triangle. Just do that, gets them all at once. So 1/2 perimeter would be 12 times 4, or 12 plus 12 plus 12 plus 12. And then the slant heights, well, we don't know that yet, but I could calculate it using this green triangle. So I'm going to do that work. I'll do that work right here. So I've got 6 squared and L squared. So L squared plus 6 squared is going to equal 15 squared. L squared plus 36 is 225. So L squared, if you subtract 36 from both sides, looks like that would be 189. And then the square root of 189 we'll just leave as that for now. So L equals the square root of 189. If you plug that in, let's see what we get there. So this would be 1/2 of 48. That'd be 24 times the square root of 189. 24 times the square root of 189 looks like that is 329.9 rounded off. So approximately 329.9, and that would be inches squared on this one. Surface area is going to be that plus the base. The base is a square here. That's going to be very easy to calculate. So lateral area, we add that part first, the 1/2 PL parts, which we've already calculated, and then we just have one base. So 1B, not 2B, like with prisms. So this is going to be 24 times the square root of 189, or approximately 329.9, plus the B, the base part, is 12 times 12. So we put this into a calculator. I'm just going to take what I had here and add 144 to that. That gives me my answer, 473.9. That would be inches squared. So 473.9 inches squared. The volume of a pyramid, 1/3 base times height. You can take 3 pyramids of the same base size and height as a similar or a matching prism. It would take 3 of those pyramids to fill that prism up. So 1/3 base times height, 1/3. Have we calculated the B already? Yeah, that's 12 times 12, or 144. And the height of this, well, we have to calculate that here. So we would have, in this blue triangle, we would have h squared plus 6 squared would equal L. L was the square root of 189, so the square root of 189 squared. That'd be h squared plus 6 squared, or 36, I should say. I want to simplify that, is 189. You subtract 189, or do 189 minus 36, you've got h squared, and that's going to be 153. So h is the square root of 153. So let's see what happens. If we plug this in down here, this would be 1/3 times 144. 1/3 of 144, that is 48, and 48 times the square root of 153, that's approximately 593.7. So approximately 593.7 there. If you were to give an exact answer, we would say 48 times the square root of 153, but an approximate answer would be that many inches cubed. Number 13 now, a regular solid. We've got a regular pentagon for the base. We're going to make that assumption that this is a regular pentagon, you can make a triangle, and you could make 5 of these triangles. To figure out the volume, I'm going to have to figure out that apothem value right there eventually. So I'm drawing that in, calling that little a, and we're saying 10 is the height of this pyramid. So figure, it's a pyramid, it's a pentagonal or a pentagonal pyramid. The lateral area is, for any pyramid, you have 1/2 times the perimeter times the slant height. So on this one, it looks like we have, let's look at this green triangle right here. This would be my slant height right there. So I don't know that part yet. I don't know what this is, but I know that whatever that is the apothem. So it's going to match up with that part there. So I'm just going to make, yeah, I'll just leave it like that. So you can see I could have just drawn in one triangle right here and use that to find apothem and slant height. So I'm going to try to figure out whatever I can first based on the information that's there in the picture. So this is going to be 1/2. The perimeter is pretty easy. That's 6 times 5. The slant height's a little tougher. To figure out the slant height, I would need to know the apothem. And so I'm going to have to figure that out. So it looks like this is 6. I could assume that this is 6 all the way from here to here. And that means I could say that this is 3 and this is 3 right there. So let's draw, I'm going to draw this triangle off to the side. And it looks like we're going to have to use some trigonometry to figure some things out here. This angle right here, I know that's going to be 36 degrees because that's 360 divided by 5 split in half, cut in 2. So 36 degrees right there. I know that this side is 3 right there. That would allow me to figure out what the apothem is, the A value. So the A value is also the same right there. So I've got, looks like that would be tangent. So tangent of 36 would be 3 over A. If you cross multiply, you're going to get A times tangent of 36 equals 3. And if you divide by tangent of 36, you get A is 3 divided by tangent of 36. So that value right there, I could round that off. I think I should do that just to get an idea of what that approximately is. So approximately 4.129146. I'll round that off. I'll use 6 digits for now. So that gives me an idea. That seems like a reasonable value. It seems like that would be a little bit longer than that. If that angle is slightly smaller than this one, that would be 54 right there. So that seems reasonable to me. So I'm going to use that value to figure this value out. So look at this. I'll call it the purple triangle here. So we've got purple triangle. You got a 10 leg, and then you have your slant height as the hypotenuse. And you've got this apothem right here. To figure out what that slant height is, we can now say that 10 squared plus the apothem squared, which is 3 divided by the tangent of 36, you square that, that would equal L squared. So from there you got 100, and then whatever that is, you're going to take the square root of both sides eventually, so I can just do that here. At this point I'm going to round this off. So I'm going to take the square root of that whole thing, the square root of 100 plus 3 divided by the tangent of 36. Now if you want to use this value instead of 3 divided by the tangent of 36 and square that, that would work as well. Just make sure you don't round too much too early, because then your answer gets really thrown off in the end there. So it's 36 tangent. Close that up. I think I got 3 parentheses of the way I typed it in the calculator. So we have to have that squared though. So let's see what we get. Let's see if this seems reasonable. 10.8. I would say that definitely seems reasonable because this is about 4. This is 10. 10.8 seems like a legitimate estimate right there. So I'm going to say 10.81895.765. I'm going to use all the digits my calculator gives me for now, so I can get the best answer possible in the end. So just double checking that. Yep, that looks good. So I have 10.81895.765. So if I plug all that into a calculator, I'm basically taking 30 times a half, that's 15. So I take that number times 15, and it looks like I've got 162.3. So that is rounded off 162.3, and that would be meters squared. Surface area is going to be that part, 1/2 PL plus the area of the base. So we've done a lot of work already that would help me find the area of the base. So I'm going to have approximately, I'm going to write that in for the 1/2 PL. I already figured that out. The lateral area was that. But then the base is 1/2 times the perimeter times the apothem. So you've got 162.3 plus 1/2. The perimeter is 6 times 5. So 1/2 of 6 times 5. And the apothem, we were saying, was 3 over the tangent of 36. If you type that in or write that in instead, that's going to be very, very close as well. For now, I'm going to write it in like this so I can get the best possible answer. Yeah, there we go. So if I close all those parentheses off here, I still have this saved in my calculator without rounding, so I'm going to keep it there. This would be half of 30, and then times 3 divided by a tangent of 36. So if I put all this into the calculator, I've got 15 times 3 divided by the tangent of 36. Looks like that's going to give me 224.221. So approximately 224.2. And that would be meters squared. And again, if you would have used this, not rounded off too much at all, right here you'd get the same answer. If you rounded this off a little too much, then you might be off by a tenth or two. Get that best answer possible whenever possible. The volume of a pyramid is going to be, excuse me, so 1/3 area of the base times the height. We know 1/3. We know the area of the base is this value right there. So I'm saying 1/2 of the perimeter times the apothem. 1/2 of 6 times 5 times 3 over the tangent of 36. If you had calculated what B was approximately, you could put that in place of that big thing that I wrote there, that part that I wrote there. And then you've got the apothem. Well, that's already in there. So, but the height, I mean. So you got the height is 10. So if we put this into a calculator, it looks like we get about 206.5 meters cubed. Number 14, we've got kind of an odd looking shape here, but we are going to stretch our thinking a little bit on this one and find the surface area of that shape and find the volume of this shape. And personally, I think the volume is a lot easier to figure out than the surface area on this one, because really all you have to do for the volume is figure out the area of this rectangular prism, the area of this rectangular prism here, and then the area of this rectangular prism, this other big one here. So this one and this one are the same, and then this one is just a small rectangular prism there. So we have the volume would be, looks like 2 times 4, the area of the base, you could call this B, 2 times 4 times the height, 9. So that's the volume of figure 1, you could say, and this I could call figure 2, and this one I'll call figure 3. So this is the volume of figure 1. Oops. So you'd have 8 times 972. The volume of 2 is going to be the same thing. So 2 times 4 times 9, another 72, and the volume of 3, that rectangular prism, looks like it would be 1 by 4. I didn't go far enough with this. That should have been 2. Oops. Should have been all the way back to there. It would go that far. So this would be 4 from here to here. And this would be, if this is 2 and this is 2, and this is 8 all the way across, that would be 4 here as well. So you've got 4 by 4 by 1 rectangular prism there. You've got a 4 times 4 times 1. That would be 16. You add all these together, and the sum is 72 plus 72, 144, plus 16. Looks like that would be 160, and that would be meters cubed. So that would be the total volume, 160 meters cubed. Now the surface area, I'm going to do that in green. So I'm going to erase this stuff that I had done here. Surface area is a little tougher. It'll take a little more work, but let's see what we got. So I see this, I could say, is shape 1. So shape 1, there's going to be a shape 1 down there, and there's going to be a shape 1 down here. So I'm going to have 4 of those for surface area. There's going to be four of those, 4 ones. And each one, you're going to have 4. Each one would be 2 by 4. So 4 times 2 times 4, that's 4 times 8, so 32 for those 4 parts. Now we're also going to have shape 2 here. This is going to go all the way back to here. That would be showing. And you'd have another 2, shape 2 under there. And so this would be, there's 2 of those. I don't see any others of those. So there's 2 2s. And so we would have, this one is going to be a 4 by 4. We already said that it has to be 4 across here. Since this is 8 all the way across, 2 is here and 2 is here. So you'd have 2 of those. So I should say 2 of the 4 by 4s. So 4 times 4 times 2, that's 32 again. Surface area for, well, what other shapes do we have? We've got these shapes here. You'd have a shape that size there and there. I'll call that shape 3. And I'm just trying to make sure I get all of them. So you've got surface area, you have 2 of those, 2 3s. And if you come up with another way to organize your work for this, that's fine, as long as it's logical, as long as I can follow what you're doing. That one's going to be a 9 by 4 though. So this is 9 by 4 here. So you've got 2 9 by 4s. That's 2 times 36, which is 72. And then looks like we've got these shapes. So this would be, well, if this is 1 and it's 9 all the way here, and we're going to assume half of it's here, half of it's here, that would be 4 by 4. And you're going to have 4 of those. You're going to have another one right here like that. And you're going to have another one here like that, and another one here like that. So you have 4 of those, 4 4s. And so you'd have 4 times 4 by 4. Each one would be 4 by 4. So you've got 16 times 4, that's 64. And then finally, you've got, well, the H part. H here, you'd have an H in the front, and you'd have another H in the back. So you've got 2 H's. So you have 2 of those, 2 5s, you could say. So the whole thing here, right here, all the way around there. Well, it would be this. You've got 2 of them. Oops. You've got 2 of these. So you've got this part. That would be 9 by 2. So 2, I'm going to say 9 times 2. And you've got this little part here, that'd be 1 by 4. And you've got another of those 9 by 2. So plus another 9 times 2. Let's see what that is. 18 plus 18 would be 36. 36 plus 4 would be 40. 40 times 2 would be 80. So the sum of all of these, I think I've got everything there. I got all the bottoms. I did the bottom and the top there. I got the H's. So it seems like I have everything. This would be 32 times 32, 64. 64, 128, that's 130, plus 70, 200, plus 80, 280. So the sum of those, you've got 280 meters squared. That is your total surface area for that shape. So 280 meters squared. So is that a tougher one? Yes. Is there a nice formula that works for an irregular figure like that? No, you have to think of it literally. Think of the area of the surface and think of the volume of the pieces and put them together. Number 15, find the surface area of the shape put together. So that's important here. Surface area, we wouldn't see the circle. We wouldn't see the great circle. So we have to keep that in mind. So the surface area is going to be the hemisphere, surface area of the whole thing, of the cone, plus the ice cream cone, you might say, would be the surface area of the cone part and the surface area of this part. So we would have, for the cone, just the lateral area would be showing. Just the pi RL would be showing. So this is the cone portion. And for the hemisphere, for the sphere, you can only see half of the sphere, hemisphere. So we would have 2 pi r squared instead of 4 pi r squared. Could you see the great circle underneath there? No, that would not actually be showing. So this would be a hemisphere instead there. Just 2 pi r squared because that circle, extra circle, isn't showing. So we have 4 times, radius is 5, slant height is 13. That's given to me. And then the radius is the same for the hemisphere. So it's another 5. This would be, it looks like 65 pi. Be 25 times 2, 50 pi. That is 115 pi, which is approximately, if you put that into a calculator, 115 pi is about 361.3. So approximately 361.3, and inches are my units, so inches squared. Number 16. Find the difference between the surface area of the cylinder and the surface area of the sphere if the diameter is 12. So if the diameter is 12, the radius would have to be 6, halfway across. And this sphere, we can assume that it just touches the cylinder top to bottom there. So all the way, the height of the cylinder, in other words, is the same as the diameter of the sphere. It's 12 all the way there. Excuse me. So the difference between the surface area of the cylinder and the surface area of the sphere, diameter is 12. The surface area of the cylinder should be a little bit more because we have more of that showing. The sphere is going to be a bit smaller than that. So let's find the surface area of the sphere. I'll find that first. I'll find the surface area of the cylinder after that. So for the sphere, it's 4 pi r squared. That's 4 times pi times 6 squared. That'd be 36 times 4. That'd be 144 pi. And I'll just leave it like that for now. For the cylinder, surface area of the cylinder, surface area of any cylinder is going to be the circumference times the height, so 2 pi r squared, or pi r h, plus 2 pi r squared. 2 bases are showing. So you have 2 times pi times 6 times 12 plus 2 times pi times 6 squared. So that'd be 72 times 2, 144 pi, plus, so it'd be 36 times 2, that'd be 72 pi. So that altogether, really I can see the difference right now. This is 144, this is 144 plus 72. So the difference has to be 72 pi. But I'll put that together. So if I combine like terms, like pi's, you could almost say here, I would have 216 pi. And so the difference between the two is 216 pi minus 144 pi, so 72 pi, which is approximately, if we put that into a calculator, 72 times pi, about 226.2. And that would be a difference of that many inches squared being a surface area. And finally, number 17. What is the volume of the space surrounding the cone inside the cylinder? So basically we're taking a cylinder and we're cutting out a cone shape out of it. What's left in this part here as you go all the way around there? That's what we want to figure out here. So the volume of that leftover part is going to be, well, we would find the volume of the cylinder and subtract the volume of the cone. So the volume of the cylinder, let's start with that. That would be, you've got base times height, so pi r squared times the height, and that'd be, if it's 5 all the way across, your radius is going to be 2.5. So 2.5 squared times the height is 8.5. You've got 6.25 right there. 6.25 times 8.5 is going to be 53.125 pi. I'm going to leave it like that for now. The volume of the cone would be 1/3 of that. 1/3 pi r squared times h. So why don't I just do 1/3 of, I've already calculated this part, it's that right here. So I'm just going to do 1/3 of 53.125 pi. And if I type that into a calculator, I'm going to have approximately, well, I could just say it's 53.125 pi over 3 if I wanted to give an exact value, but that's about 17.708. It's actually that exactly if I put the repeating symbol above the 3. So we're going to use this, and so the difference, or the volume inside there, is going to be volume of the rest, I guess you could say, or the remaining portion. We would have 53.125 pi minus 53.125 pi over 3. And so if I do that, let's see what I get. So this 53.125 pi is approximately 166.897 and some change. And if I subtract 17.7083 repeating from that, I'm going to get approximately, I meant to have a pi here actually, so that was throwing my answer off when I typed it into the calculator. So I'm going to have, let's retype that in, 53.125 pi minus 53.125 pi, and I'll divide that by 3, and looks like I would have about 111.3 rounded off. So 111.3, that would be inches squared. Now you could have done what we did here, or you could have actually done the volume of the remaining part would have been, since this is pi r squared h, and this is 1/3 pi r squared h, you could have just done 2/3 pi r squared h. So you would, if you did that, you would get this same answer though in the end. So that does it. If you see any mistakes, any problems, feel free to give me some comments, tell me what time that happened, and I'll try to comment and correct those mistakes in the comments. Please feel free to share this video with others, to like it, to subscribe to the channel if you found it helpful. Hope you found it helpful. Hope you do really well on your test if you're one of my students or somebody else's students, or you're just learning more about geometry from another school. Do the best you can, study hard, have a good night, day, whatever time it is for you, and I will catch you later. Bye-bye.